So this is chapter 9. It's firearms, tool marks, and other impressions. So the first thing that the chapter discusses is what guns, it explains guns. Okay, so what guns are. And there's 3 main classes that are the most common kinds of guns. So there are single shot pistols, which only fire a round at a time. Okay, there are revolvers, and revolvers have several firing chambers that have a revolving cylinder, so that's where the revolver thing comes from. So there are swing out revolvers, break top revolvers, and solid frame revolvers. Okay, then there's also semi-automatic pistols, and they have a removable magazine, so the magazine can be taken out, and that the magazine's where the bullets are going to be put. So we're going to fire 1 shot per trigger pull, so only 1 shot when you pull it. So that says the 3 most common types of handguns are single shot handguns, revolvers, and semi-automatics. Okay, so here's a picture of a swing out revolver. So it's kind of like a Wild West kind of gun maybe. So the cylinder swings out to the side and then the bullets are loaded into there. Okay, and then another picture is a semi-automatic pistol, and you can kind of see where the cartridge, you can see in a way, you can see how the bullets are going to be loaded into it. Okay, and they're going to be in a like a cartridge or a magazine, so they go into the magazine and then up into there. And this picture, it's a cutaway, so you can see how the bullets are going to be loaded into the chamber. Okay, now another type of firearm are long guns. So long guns have a long barrel on them, so they can be single shot, repeating, semi-automatic, or automatic. Okay, so shotguns, they're divided into shotguns and rifles. So shotguns contain shells. Shotguns use shells as ammunition, and they have ball-shaped projectiles in them, and that's the shot. Okay, so that's where shotgun comes from, because the shot is going to scatter when it comes out. Okay, so they have a narrowing of a smooth barrel. Oh, wait a minute. Sorry, I'm kind of thinking about this wrong. There's, you can narrow the barrel of a shotgun with a choke. Okay, so if you narrow it, that's going to concentrate the shot when it's fired. So it's going to go to like a more specific region. So choke is something you put in the barrel. Okay, then there are rifles. So rifles are, the barrel is rifled. Okay, so we'll talk about rifling in a minute. So the barrel is going to have these things called lands and grooves in it, and that's going to cause the bullet when it comes out to actually spiral. So the bullet ammunition, when it comes out, it's going to be impressed. Okay, so impressed means like you're putting marks on it. So impressed with things called lands and grooves when the rifle is fired. So there's a picture in your book of a bolt action long gun. So bolt action long gun has a bolt mechanism that's going to expel the spent cartridge case, and then you can load the next round and cock the hammer. Okay, and then there's another picture in the book, which is a semi-automatic long gun. So with the semi-automatic, what happens is you're going to use the energy from the firing reaction. Okay, so one thing's going to go forward, another thing's going to come backward, and that's going to expel the cartridge case and load the next round and cock the hammer, so you can fire faster. Okay, rather than having to move the bolt to advance, to move the bullet. Okay, so shotguns typically have they have a smooth barrel in them, so it's not rifled. Shotguns, they fire small lead balls or pellets, and they're in a shell. So I'll have some shells at lab. They're not impressed with characteristic markings that can be related back to the weapon. Okay, so when they come through the barrel is not putting marks on the shell casings, and then the pellets are going to spread. So it's going to be harder to get, or it'll be different ways to get, I guess, evidence off of them. Okay, now with shotguns, when they talk about gauge, the gauge is the diameter of the shotgun barrel. The higher the gauge number, the smaller the barrel's diameter. So 28 gauge has a really small barrel, whereas 12 gauge has a bigger barrel. Okay, now introduction of like forensics and guns. So structural variations and irregularities in the weapon can cause, so there can be scratches, there can be nicks, there can be breaks, there can be wear. Okay, so all those things can permit a criminalist or the lab person to relate the bullet to a gun, a scratch or an abrasion mark to a tool. Okay, so like if somebody's stabbed with like a screwdriver or something, or a tire track to a particular automobile. Okay, so you can get individualization in firearms and tool mark examination. So it is possible to do that. So this would be a good thing to use for evidence. Okay, now gun barrel markings. So the inner surface of the gun barrel leaves markings on the bullet that passes through it, and the markings are peculiar or unique to each gun. So the gun barrel, you can YouTube a video of how to make a gun barrel for a rifle. So a gun barrel is produced, they take a solid bar of steel, and then they're going to hollow it out by drilling it. So the drill is going to leave microscopic marks, so it'll leave marks on the inside of the barrel, and they're going to be irregular, and they make each barrel unique. Okay, so in order to make a barrel for a rifle, what they're going to do is they're going to make spiral grooves through it, and that's called rifling. So the purpose of rifling is to impart spin to the projectile when it's fired, and that's going to help keep the bullet going on a straight path towards where you're trying to get it to go. If it came out and it wasn't rifled the way that bullets are designed, it might go end over end instead of spinning. So rifling it's good for the bullet. It keeps the bullet going the right place, but it's also going to be able to be used as a characteristic to identify evidence. Okay, now caliber is a vocabulary word that's used. So caliber often refers to the diameter of the gun barrel, and they're usually talking about it in 1/100th of an inch or in millimeters. Okay, so the manufacturers usually use a specific rifling process, and when they use that specific rifling process, that's going to give the gun a class characteristic. So you can say, okay, this is a Ruger, this is a Marlin, this is whatever, okay, so this is a Benelli. So because they use a specific process to rifle their barrels, the guns can be classified according to class. Okay, now they talk about grooves and lands. Okay, now grooves and lands are two vocabulary words that are used to describe the rifling in a gun. So the grooves, it kind of goes up and down. So the grooves are going to be the low parts. Okay, and then the lands are the raised portions. So the rifling kind of goes, I don't know how to describe it. It goes up and down, and it kind of like it goes down and then it goes up and it plateaus and then it goes back down and plateaus and goes up and plateaus. So the lands are the raised portions and then the grooves are the low-lying portions. So you can use the lands and the grooves to identify weapons. Okay, this picture is a cross section of a barrel with 6 grooves. So by looking at the cross section, you can see the low-lying parts and then you can see the higher parts. The diameter of the bore is the caliber of the weapon. Okay, now striations are, a striation is a line. Okay, so striations are fine lines that are in the interior of the barrel. So the striations form the individual characteristics of the barrel. So it's what makes each gun distinct. So it's the inner surface of the barrel of a gun that leaves its striation markings on a bullet that's passing through it. Here is a picture of a bullet, and it has rifle markings on it. So it has grooves, like scratch marks on it where it came out of the barrel of the weapon. Okay, so bullet examination. So no 2 rifle barrels will have identical striations. So the number of lands and grooves and their direction of twist are points that you can use to compare them. So when you're first starting out, you're going to compare the lands and the grooves, and then you'll go into the small striations. So usually if you have the weapon and you have a bullet, you're going to have to test fire a bullet to use as comparison. This is an image of a woman test firing a handgun. So she's shooting it into a water tank. So in ballistics testing, the suspect firearm is fired into a water tank. The bullet's slowed and stopped by the water. Then you can fish it out of the water and you can compare it to the bullets from the crime scene. Okay, a comparison microscope is used to look at them. So if the microscope that we used as a comparison microscope, we took pictures and put them in there and compared them. With this comparison microscope, it's got two like head pieces, so you can look at 2 bullets at the same time. We did it digitally. So this is a photograph of 2 bullets through a comparison. So there are 2 bullets in here. So instead of having just digital images, you're seeing two bullets. So you can see the striations and how they line up. So the lines just line up between. Okay, so now firing a weapon. Okay, so you pull the trigger and that releases the weapon's firing pin and that causes it to strike. The firing pin strikes the primer and that primer is going to ignite the powder. So when the gunpowder is ignited, the gases expand. So the expanding gases generated by the burning powder propel the bullet forward through the barrel, and it pushes the spent cartridge case or the shell back with an equal force, and it goes back against a part of the gun called the breech face. Okay, so the shell is going to have markings on it from its contact with all the metal surfaces. So the firing pin, the loading mechanisms, the breech face. Okay, so now there's computer imaging that's done now so that you can store the information. So store pictures of bullets that are fired. So you can store bullet and cartridge surface characteristics just like we store fingerprint files. Okay, there were 2 initial databases. So one is called DrugFire, and that was FBI. And then there's another one called IBIS, and that was coordinated by the ATF. So what happened is DrugFire and IBIS were combined, and that became, I'm not sure if you're supposed to say it, NIBIN, N-I-B-I-N. So it's the National Integrated Ballistics Information Network. So you can search the images just like you can with a fingerprint file. So there's 1.6 million images that have been collected so far in the United States. Okay, now with the computer imaging, it's So it's just like the fingerprinting. So you can use the imaging to make an initial comparison, but the ultimate decision is going to be down to a real person and using a microscope. Okay, now how do you determine how far away someone was? So distance determination without a suspect weapon. So when a firearm is discharged, unburned and partially burned particles of gunpowder, in addition to smoke, they come out of the barrel along with the bullet, and they're going to go towards the target. Okay, now if the muzzle of the weapon is close enough to the target, then the gunpowder products are going to go onto the target. So the distribution of the gunpowder particles and the other residues around the bullet hole allows someone to try to figure out how close the gun was when it was fired. Okay, now the precise distance from which a handgun or a rifle has been fired must be determined by means of a careful comparison of the powder residue pattern that's located on the victim's clothing or skin against test patterns made when a suspect weapon is fired at varying distances. So you have to compare them to really, really, really figure it out. Okay, now, what you're going to get is you'll get a star-shaped, or they call it stellate, tear pattern around the hole if the weapon is in contact with or less than an inch away from the target. Okay, so it makes a star-shaped tear if it's really, really close. So if it's touching it or if it's 1 inch away. Okay, now, you can get a halo if the bullet's discharged 18 inches away or less. Okay, so it forms like a halo around where the hole is. Okay, now, you can get scattered specks of unburned and partially burned powder without any soot if the shot is fired up to 25 inches away. And then you also get this thing called a bullet wipe if you're greater than 3 feet away. So you just get a dark ring around the hole, but you don't get any powder residue. So star shape is touching, okay. Halo, 18 inches or less. Then scattered specks is like up to 25 inches. And then a bullet wipe is like greater than 3 feet. So you don't really get much on there. So in the book there are pictures. So the first picture is a test powder, powder patterns made with the Glock 9mm Luger fired at the following distances. So the first one is contact. So there's a star where the fabric is teared. Okay, the second one is 6 inches, so you can see kind of like a pattern around the hole of the powder. Okay, at 12 inches, there's less powder around the hole. And then 18 inches, there's just kind of like a speckles. It's kind of random speckles. There's no circle or anything around the hole. Another contact on fiber, it really rips and it makes a star. Okay, another way to see to see how close it's been. Sometimes on fabric you can't see the gunpowder because it matches the fabric. So what they do is they use an infrared photograph. And with the infrared, then you can see the pattern of the gunpowder on the fabric. Okay, now a way to test for gunshot residue is a test that's called the Grice test. So what it's looking for, so it could be used on fabric or it could be used on fabric to see if there's gunpowder residue on there. So what it looks for is the presence of nitrites. Okay, now another thing that we can look for is a primer residue on the hands. So the firing of a weapon not only propels residues towards the target, but the gunpowder and the primer residues are going to be blown back towards the shooter. So as a result, traces of these residues can be deposited on the firing hand of the shooter. So examiners, what they're looking for is they look for barium and antimony. So they're looking for two chemicals, barium and antimony, and they're found on like the relevant portion of the suspect's hand. So like the web between the thumb and the first finger, the back of the hand, and then it gets transferred to the palm. Now, the problem is when you wash your hands, right, they can get primer off and they can smear primer around. So it doesn't necessarily work to search for primer residue. It's not always a good test. Sometimes they'll do swabs and they'll use scanning electron microscopy to look for gunpowder particles. This is a picture of the stubs that they use to look at somebody's hand. So they use like a piece of tape, and the tape they're gonna put on someone's hand and peel it off, and then they can look for residue on those pieces of tape. But they're called stubs because there's like a stub of paper on the well, some of these are tubes. Okay, so they're little tubes, and they'll have tape, so adhesive stubs. So they take this tube, it's kind of like a lipstick or a chapstick tube, and it's got tape on the end of it. So you take the cap off, the tape is under there, and they're going to stick that onto somebody, and then they're going to take it off, and then they're going to put the cap back on. Okay, and you'll have one for different parts of the hands. So this is a picture of them using the stub. So the stub is just, I kind of think of it as like a chapstick tube, and they stick it on, and they're going to try to take a sample off of the hand to look for gunshot residue. Okay, now when firearms are collected for evidence, so they're going to be collected by holding the weapon by the edge of the trigger guard or by the checkered portions of the grip. Okay, now before they're going to be sent to the lab, you need to make sure that they're not loaded, because you don't want to accidentally discharge a loaded weapon. Okay, it is possible that the weapon may need to be unloaded. Firearm evidence must be marked for identification, so usually it's a tag on the trigger guard, and you guys know this, a chain of custody must be established. Okay, bullets, cartridge cases, and shotgun shells that are recovered at the crime scene need to be packaged in properly labeled evidence containers. The obliteration of striation markings that might be present needs to be avoided. So you don't want to accidentally smudge away or damage some of the markings that could be used to identify where the bullet came from. Okay, the investigator must protect the bullet by wrapping it in tissue paper before they place it in a pill box or an envelope to ship it to the crime lab. Okay, now serial numbers. So increasingly, someone who is a criminalist is requested to restore a serial number on a weapon when it's been removed or obliterated, so destroyed by grinding, rifling, or punching. Restoring of serial number is possible through chemical etching. So depending on what the metal is, you use different chemicals to etch it. The metal crystals in the stamp zone are placed under a permanent strain because of when they're stamped. So the strain extends a short distance between the original numbers. So if you can etch it, you can often restore the numbers. Okay, now the next part of this chapter is about tool marks. So a tool mark is any impression, cut, gouge, or abrasion that's caused by a tool coming in contact with another object. Okay, careful examination of the impressions can reveal important class characteristics such as the size and the shape of the tool. Okay, it's the presence of any minute imperfections on the tool that allows us to figure out if that was the tool that's used, so it gives it individuality. Okay, the shape and the pattern of imperfections can be modified depending on like how you use the tool, right? So damage and wear during the life of the tool is going to give it individuality. It's a vampire, and she got stabbed with a screwdriver in the eye. So you could go back and you could look at how they actually used the screwdriver before they stabbed it to see if it matched. Okay, and I was just reading a book, and it was okay. So the comparison microscope is used to compare crime scene tools. So when it's practical, the entire tool or part of the object bearing the tool mark should be submitted to the crime lab. Okay, so under no circumstances must the crime scene investigator attempt to fit the suspect tool into the tool mark, okay, because it's going to change. It could change the mark, and it will raise serious questions about the integrity of the evidence. Okay, now other kinds of impressions, so like shoe, tire, fabric impressions, could be important evidence. So before any impression is moved or handled, it needs to be photographed, making sure that you have a scale in there to show all the observable details of the impression. Okay, if the impression could be removed from, like if it's on paper or a floor tile, then you should remove it and take that whole thing to the lab. But if the surface can't be, then you need to lift it, and depending on what it is, there's different protocols for lifting it. So it could be lifted kind of like a fingerprint. When shoe and tire marks are present at a crime scene, it's important to preserve them with photography and with casting. Okay, now where there's bloody footwear impressions, where it's faint, sometimes you can add chemicals to enhance the bloody impression. Okay, and you have to have enough points of comparison or the uniqueness of points in order to say that the impression came from a certain source. Okay, and then there's computer software that's available. They have shoe prints, tire impressions. They can get bite mark impressions. There's lots of things that you could get impressions of that can be useful in homicide and rape cases.